Alright, we're done with the facing operation, so we're going to start a 2D pocket operation. This one right here, the setup, the double-sided setup, we'll talk about that later. Something I want you boys and girls to start doing is in the model tab, or excuse me, the design tab, right click and create a sketch on this face. Create a text box somewhere, put your name on there. That'll work. Just so I can identify whose is what later on as you turn these in. So back to my manufacturer. I'm not going to spend a whole lot of time talking about setups because you've done a couple by now. You kind of know how it goes. We are going to talk about cutting a pocket. So I'm going to do this right here under my 2D toolpath options, my 2D machining operations. I'm going to pick 2D pocket. Now the same box pops up that we had before with the facing operation. I'm going to select my tool. This time I'm going to use a 1/4" flat end mill. Yep, coolant is disabled. Speeds and feeds, we're going to leave them alone because we're simulating. Geometry, it's important that you pick the bottom of this pocket. Because what that'll do is it will also not only tell the machine, hey, you're going to cut all the area out of here, all the material out of this area, but it's also going to set your machine for the height. I mean, it won't look like anything, but when you get to bottom height, it will say selected contours, which is the area that you clicked. Don't worry if you mess this up and you click something errantly, you can always go back and edit, just like all of the other Fusion 360 work we've done this year. Geometry, we're good. Heights, we're good. I pretty much leave all those clearance and retract heights alone. Passes, you might want to think about a multiple depth here. If I were to take a real thin tool, skinny tool, and plunge it all the way into the material and try to cut, I might break the tool. So what I can do is check this multiple depths. It's in the passes tab and set it for the diameter of the tool or 0.2. I just kind of leave it at 0.2. For simulation, it will remove a large amount of material in simulation mode, but in reality may not be something we want to try to do. So I click that so I get a good idea of what it's going to look like when it goes to the machine. My linking tab, I'm just going to kind of leave this alone and see what we get. If you can't see the OK button, click the little arrows and they'll collapse and then you can see your arrows. All right, so I'm going to get a helical lead in, which is okay. It goes in a little sort of spiral as it cuts into the material. Because I checked multiple depths, you can sort of see here that there are two sets of tool paths, two sets of blue lines. One is not quite the full depth, and one is the full depth. So let's simulate this and see what it's going to look like. So it's going to go around, and then it's going to go down again, and then it's going to go around, looks like the rest of the way. Much safer to do it that way. It takes a little bit longer, but for school, for learning, I'd rather err on the side of safety than production. One thing that you will notice, oh, I do have to be in simulation. One thing that you will notice is when I get done with my simulation and I look at this corner right here, there's a little radius in here. That's because the tool is round. There's nothing we can do to get rid of that radius. We can put a smaller tool in there, a smaller diameter tool in there. It would make that radius smaller, but that's just the nature of it with this type of milling operation is you can't have a sharp inside corner like that, like what you had originally drawn. This is what you need to do for your 2D contour. Go ahead and snip this, screenshot it, and turn it in. Thank you.